And this is the next section, section 4.3, chapter 4 on integrals. Okay. Here is the most important theorem of calculus, the fundamental theorem of calculus. It is a deep result. If you don't understand it, give it some time. Look at this material again and again. Look at these videos again and again. And of course, solving problems help a lot. The fundamental theorem of calculus consists of two parts. Let's start. The fundamental theorem of calculus is appropriately named because it establishes a connection between the two branches of calculus. One is the differential calculus and the other is the integral calculus. Differential calculus is where you take derivatives. Integral calculus is where you take integration. All right. Integration means finding antiderivatives. It gives the precise inverse relationship between the derivative and the integral. The first part of the fundamental theorem deals with functions defined by an equation of the kind gx equals integral a to x ft dt. So notice this is not typed correctly. A should be here, x should be there. Integral a to x ft dt, where f is a continuous function on closed interval ab. Notice it is ab, not ax. So that is an important material to keep in mind. And x varies between a and b. In other words, look at g. G depends only on x, which appears as a variable upper limit in the integral. Okay, a to x ft dt. X is fixed number, then this integral is a number. You see, what does this integral represent? It represents area from a to x. If you change x, then you start getting different areas. And that is the definition of g. G is a function. It's basically the area function from a to x. Area of x is starting from a, go until x. As x changes, area changes, and that's how g is defined. Okay, so understand this function. It is not a to b, it is a to x. So you have fixed a and you are changing x. Okay, here is a pictorial representation. If f happens to be a positive function, that is, it is above the t-axis, then gx can be represented as the area under the graph of f from a to x. So when x is a, you have no area. You start off with 0. As x changes, you get more and more area because my graph is all above. If I go below, then I start subtracting as well. You understand? So basically, as x changes, my area changes. So think of g as the area so far function. All right. Here is a concrete example. Let's look for gx equals integral 0 to x. Okay. Find the value of g0. All right. So area from 0 to 0. So no movement. G of 0 will be 0. All right. Next. Find g1. So I'm going, my x, that is area goes from 0 to 1. All right. So that gives me just this triangle. All right. So what is the area of this triangle? Half base times height. Half times 1, that is half, times 2, that's 1. All right. So area half base times height. 2 cancels the 2. Total area is 1. So you found g of 1. Next, find g of 2. So you are starting from 0, always starting from the same point. The upper limit changes. So you are still starting from 0 and you are going until 2. So you have already calculated this. This area was 1. What is this area? This is a rectangle. So you have 1 times 2, 2. Add 2 to the 1 you have already found. All right. And that is, area is 3. Next, G3. So you're starting from 0, going until 3. So you have area 1 here, area 2 here, and this looks like a little more than 1. All right, it is curved, it is not a straight edge. So, all right, 2 to 3 of F. All right, they claim it is 1.3. So far whatever you had was 2, 2 here, 1 here, that's 3, and 1.3 over here, that's 4.3. G at 4. So you have all of this area, that was 4.3 so far. Now you want to subtract this. Why subtract? Because it's below the t-axis. All right. So how much do you subtract? This they have estimated to be negative 1.3, negative because it's below the t-axis. So far you had 4.3 and then you are going to add negative 1.3. So you now are back to 3.2, starting from 0 until 4. Next, until 5. So you want to subtract once more. Okay, so we missed it. Yeah, to 5. So you go, all of this is 4.3. This is subtracting 1.3 and another 1.3. Okay, so you have to subtract all of this. In all, you get 1.7. So these are the values to sketch the graph of G. At 0, your area was 0. At 1, your area was 1. At 2, the area was 3. At 4, the area was at 3, the area was 4.3. At 4, you start reducing. At 5, you have reduced.